Welcome back. In this video, we will learn how to write code in C for Postorder Traversal in a binary tree. This is the recap of creating a binary tree. Now, these are the two header files you need, and this is the structure of each node. Here you see the root is set to null, and this is the code for the function insertion that creates a new node with the data passed as a parameter. Here you see the calling statement. Insertion A has been called, and A will be passed to the cat data over here, and with that data the new node will be created here, and with the left and right child to null. This newly created data will be pointed by this root pointer, which is initially null over here. If you follow these codes, then you'll get a tree like this. In one of the previous videos, I have explained how the creation of a tree actually works. In the Postorder Traversal, we will use the same binary tree as we have used in case of pre-order and in-order. In pre-order and in-order, we had one array that was acting as a stack. Here we have two arrays. One array is acting as a stack as before, but here we have another array that will hold the sign of each data that will be stored inside this stack. These are the addresses as before, and here is our main. Here we have stack 20, but here we have only 7 cells to store the addresses to hold this small tree. Int choice for this menu, and top is set to 0. We also have a sign variable of cat type and the sign array 20 of cat type. We also set the stack top, the sign array top, both of them to null. So after this, it will be looking like this. For the traversal, we get entered into this while loop. We have the choice here. You must ask the user to press 1 for creation of the tree first, and then in this video, we will go for explaining the choice 2, which is having this Postorder Traversal. We have popped item pointer as before and PTR pointer, both of struct node star type, and both of them are set to root. In the previous video, I explained why the popped item has been initialized to root. Now we go for the do while loop for the traversal. First, you see that there is an if condition, that if PTR is not null, then you increment top. Top goes from 0 to 1. Then you store PTR's address into stack top. That means PTR is standing at 781. So 781 will be stored here. And the next line says that sign array top equal to plus. That means a plus sign is inserted here. So 781 is associated with a plus sign. This is the whole if block. And within this if block, we have already done first 3 statements. That means increment up top, store the address of PTR into stack top, and also we have stored a plus sign inside the sign array top. Now our algorithm says that you have to move PTR towards the leftmost part so that PTR will come down to 513. But before leaving 781, you have to check whether there is a right child or not. If there is a right child, then that child, rather the address of that right child, will be stored here with a minus sign. So this is a check. If PTR right is not null, the case is here, PTR right is C, that is 291. Then you increment top. So top goes to 2. Then stack top equal to PTR right. Now PTR right means 291. So 291 will be stored here, and you push a minus sign inside the sign array. So a minus sign comes over here. So 291 is associated with a minus sign. You remember from the previous video that whenever you are pushing some node, which is the current node, then you push that node with a plus sign, and whenever there is a right child to be pushed inside the stack, it is associated with a minus sign. After this, we move PTR to PTR left. So PTR left is 513, so PTR comes over here. This cycle is over. We check popped item is null or not. Yes, it is not null. So we run this do while loop again and go for this if condition. You say PTR not null. Yes, PTR is standing at 513. So get inside and increment top by 1. So top is standing at 2. It goes to 3. And then you push PTR's address into stack top. PTR's address is 513. So 513 comes over here and a plus sign in the sign array here because 513 is the correct address. Next, you check whether there is a right child or not. If PTR right is not null, then you execute these three statements. PTR right is 716. So you increment top goes to 4, and 716 comes over here with a minus sign here. After this, you move PTR to the leftmost path and it comes down to 233. This cycle is over. You check the while condition, popped item is not null because popped item is still root. So you run this do while loop again. You check whether PTR is null or not. PTR is not null, so get inside this if block. Again increment top by 1 so that top goes from 4 to 5 and you execute this statement, stack top equal to PTR. PTR is 233, so 233 comes over here and with a plus sign. Next, you check whether there is a right child or not. Yes, there is a right child, that is 449. So get inside, increment top and it goes to 6. 449 comes over here with a minus sign here. Next, you execute this statement, PTR equal to PTR left. PTR's left is null now. The cycle is over. You check popped item. It's still not null. So you run this do while loop. But at this time, this if condition will not work. So we go for this else part, which will be executed when PTR is null. So here we have PTR is null. So we execute these three statements. Now you are going to pop item from stack. So pop item from stack and store the address inside the popped item. So stack top is 449. So 449 comes over here. So root has been replaced with 449. And you pop the sign from the sign array top to the sign variable. So this minus will be coming over here. Then you set top to top minus 1. So top comes down to 5. Now what will you do with this popped item? There are two jobs. The first one is that you can process the data, and the second option is that you have to push back the data inside the stack. Now when will you process the data and when will you push back the same data inside the stack? You see the plus sign. Whenever the popped item is associated with a plus sign here in this variable, then you go and process it. And if it is associated with a minus sign, then you push back the same address here inside this array with a plus sign, right? So for that, we will have a check here. But before that, we will check whether the popped item is null or not. If the popped item is null, that means this null comes out of the stack, then you will know that your traversal is over, just like you have done in the in-order traversal case, right? Now here you see that popped item is not null. So this if condition will not work. So you have to go for an else block here. So this else block will work when the popped item is not null. Now we have to check whether the popped item is associated with a plus sign or a minus sign. If it is associated with a plus sign, then you will go and process it. And if it is a minus sign, then you will set the PTR to popped item. Now what we see here? We see here that 449 is the popped item with a minus sign. So we set PTR to 449. So PTR comes over here standing at 449. Now the cycle is over. We get back to the first statement of the do while loop. Again we check whether PTR is not null. Yes, PTR is not null because it is standing at 449. So we get inside, increment top by 1. So that top goes to 6 and you set PTR's address to stack top. PTR's address is 449, so 449 is here, and you associate with a plus sign for this statement. So plus sign is here. Now standing there, you check whether the PTR's right child is there or not. You say that PTR's right is null, nothing is there. So this if block will not work this time and the control will simply jump to this statement, that is PTR equal to PTR left. So PTR becomes null again. You check the popped item is not null. Yes, it's true. So we run this do while loop again. This time, since PTR is null, then this green else block will work. There it is asked to pop item from stack top and store inside the popped item. So stack top is 449. So 449 will be stored here. Next, you pop the sign of this array at 6, that is plus, will be popped and stored in the sign variable, and top goes down to 5. Now the popped item is not null, so this if block will not work. We again go for this else block, and there we have to check whether the sign is a plus or a minus. We see that sign is a plus. So we process the item. That means you print the data. So the data is F, so you print F, and your cycle is over. Popped item is not null because popped item is 449. So we again go for this do while loop and we check the status of PTR. PTR is null, so this green block will be executed again, and there the stack top will be popped and stored in popped item. So stack top is 233, so 233 will be stored here. Next line, you pop the sign from the sign array top and store inside the sign variable. So this is the plus sign, so this will be popped from here and stored over here, and top goes down to 4. Popped item is not null, so we go for this else block, and within this else block we have to check the sign. We see that sign is plus, so we process it. This time D will be processed. Your cycle is over. We check the popped item, is still not null because 233 is there. So we run this do while loop again, and we find that PTR is null, so this green block will again be executed. So you pop stack top and store inside the popped item. So 716 is the stack top. It will be stored inside this popped item, and you pop the sign array top and store it inside the sign variable. So minus will be popped and it will be stored here. Top goes down, and we go for this else part because popped item is not null, and we check the sign. This time it is minus, so this else block will work. Set PTR to popped item. So popped item is 716, so PTR will be set to 716 like this. This cycle is over. We go for the do while loop because popped item is not null, and we find that PTR is not null. This time this red block will work. We go for top equal to top plus 1. So top goes to 4. Stack top is PTR. So PTR is 716. So 716 comes over here. Sign array top equal to plus. So this portion will be stored with a plus. And we go for checking if PTR right is null or not. Here we say that PTR right is null. So this if block will not work. It will go straight to this statement, PTR equal to PTR left. So we go for PTR left and it goes to null. Cycle is over. We find popped item is not null. So we go back for the do while loop and we find that PTR is null. So this green block will work and we go for popping. So 716 will be popped along with the plus sign here. Top goes down and popped item is not null. So we go for this else block. We check that the sign is plus. So we process it. So this time the E will be processed because 716 is there and your cycle is over. We find that popped item is not null, 716. So go for the do while loop and found that PTR is null. So again this green block will work and we have to go for popping. 513 will be popped and stored inside this popped item variable. So 513 comes over here. Plus sign is also stored in the sign variable and top goes down to 2. Popped item is not null, so this else block will work and we find the sign as a plus. So we process it. So this time this B will be processed and your cycle is over. So we check popped item is not null, it is 513. So we get back to this and find that PTR is still null. So we go for this green block and we go for popping the item So 291 will be popped and stored inside the popped item variable. Minus sign will be popped out and stored inside the sign variable, and top goes down to 1. Popped item is not null, so you go for this else block, and within this else block we find that the sign is minus here, so this else will work, and here it is asked to set PTR to popped item. So PTR is null now, so it will be set to 291. So it will go straight over here. Now this cycle is over. So popped item is not null, it is 291. So it will get back to go for this do while loop. And this time the PTR is not null because it is standing at 291. So the top will be incremented here and 291 will be stored here with a plus sign. Then it will go for checking the right child for this if condition. Yes, there is a right child. So it will get inside and increment top to 1 so that top comes over here. And the right child 116 will be stored here with a minus sign. And the PTR will be set to PTR left. This time PTR will be here at 397. I leave the job for you to complete the whole tree by following these codes. Whenever all the nodes in the tree will be exhausted, this null will come out from the stack. And at that time, this if block will work. That is, if popped item is null, then you report that traversal is complete and you use this break statement I have written over here because there is a lack of space. Okay. So this is the C code for implementing post-order traversal in a binary tree. In the next video, we will go for introduction to binary search tree. Thank you for watching and take care.